Welcome to a lesson on the law of cosines. In this lesson, we will derive the law of cosines and also solve triangles using the law of cosines. A triangle that is not a right triangle is called an oblique triangle. Until now, we have only been able to solve right triangles. However, the law of cosines will allow us to solve oblique triangles and solve new application problems. However, in order to apply the law of cosines, we must be given either side angle side, meaning two sides and an included angle are known, or side side side, meaning all three sides are known. Oblique triangles with the following information can be solved using the law of sines: side angle angle, or angle side angle, as well as side side angle. And now let's take a look at the law of cosines. For any triangle with angles capital A, B, and C, and sides lowercase a, b, and c, the law of cosines can be expressed in any three of these ways. And there are some patterns here in the equations that should make them easier to remember. Looking at the right side, whatever angle is used in the cosine function, the opposite side is used on the left side of the equation. And now focusing on the right side of the equation, notice if we have b squared plus c squared, we have b times c here. If we have a squared plus c squared, we have a times c here. And if we have a squared plus b squared, we have a times b here. Recognizing these patterns should make it easier to remember the law of cosines. And now let's derive the law of cosines. Beginning with an oblique triangle ABC, we construct an altitude from, let's say, vertex C, which forms a right triangle on the left and on the right. Where if we label the leg of the right triangle on the right side x, since the length of side AB is c, the leg in the other right triangle, the right triangle on the left, would have to be c minus x, which is already labeled here. And now to begin our proof, we focus on the right triangle on the left and apply the Pythagorean theorem, which gives us b squared equals y squared plus the quantity c minus x squared, which is here in the proof. The next step is to expand the square of c minus x, which gives us c squared minus 2cx plus x squared. And now for the next step, we apply the Pythagorean theorem to the right triangle on the right side, which gives us a squared equals x squared plus y squared, shown here on the right. And notice how our equation does have y squared plus x squared. So now we substitute a squared for x squared plus y squared, which gives us the third equation. We now know b squared is equal to a squared plus c squared minus 2cx. And now using the triangle on the right again, notice the cosine of angle B is equal to the ratio of the adjacent side to the hypotenuse, which gives us cosine B equals x divided by a. If we multiply both sides by a, we have x equals a cosine B. So now we perform a substitution for x. We substitute a cosine B for x, which gives us the fourth line. And now simplifying, we have b squared equals a squared plus c squared minus 2ac times cosine b, which is one of the forms of the law of cosines. And using a similar process, we could derive the other two forms of the law of cosines. Now that we have the law of cosines, let's look at some examples. We're asked to solve triangle ABC if angle B is 73.1 degrees, side A is 24.2 feet, and side C is 43.7 feet. Let's label the information on the triangle. Notice how we do have side angle side, and therefore we can use the law of cosines. And because we have angle B, we know we can find the length of side B using the second form of the law of cosines. This is why it's important to remember that whatever angle we use on the right side, the opposite side is on the left side of the equation, which means b squared is equal to a squared plus c squared, which is 24.2 squared plus 43.7 squared minus 2 times a times c times cosine b gives us minus 2 times 24.2 times 43.7 times cosine of 73.1 degrees. And now we need to go to the calculator. The first thing to do is make sure we are in degree mode by pressing the mode key. And notice in the third row, we are in degree mode. So going back to the home screen, we now enter the right side of the equation. And press enter. And this is the value of b squared. So this is the value of b squared. Let's round this to 4 decimal places, but then we'll also store it in the calculator so we can have the exact value. So we have 1880.4716 to 4 decimal places. And now to find b, we take the square root of both sides of the equation and go back to the calculator. But if we take the square root of a rounded value, we'll have more of an error. So let's go ahead and store this by pressing store. Let's store it in b by pressing alpha apps, enter. And now we'll take the square root of b to get a more exact value. So we press second x squared alpha apps and enter. This will be more accurate than taking the square root of 1880.4716, even though if we round the result to 1 decimal place, in both cases we get b is approximately 43.4 feet. Let's go ahead and label this. And now that we have an angle in the length of the opposite side, we can use the law of sines to determine the measure of angle A or the measure of angle C. Let's use the law of sines and determine the measure of angle A. Using the law of sines, we have the sine of angle A divided by the length of the opposite side, which is 24.2, must equal the sine of the known angle, which is the sine of 73.1 degrees, divided by the length of the opposite side, which is approximately 43.4. And now let's cross multiply and solve for sine A, and then solve for angle A. Cross multiplying, we have 43.4 times the sine of angle A equals 24.2 times the sine of 73.1 degrees. And now we divide both sides by 43.4. Simplifying, we have the sine of angle A is equal to the quotient on the right. And now to solve for A, we take the inverse sine or arc sine of both sides of the equation, which gives us angle A is equal to the inverse sine of the quotient. And now let's go back to the calculator. And when we enter 43.4, we should use the more accurate value rounded to 4 decimal places, or the square root of b. So we'll press second sine for inverse sine, and then we need the numerator in parentheses. So we have open parenthesis 24.2 times the sine of 73.1 degrees, close parenthesis for the sine function, close parenthesis for the numerator, and then we need to divide this by either 43.3644 or the square root of b. I'm going to use the square root of b. So second x squared alpha apps, right arrow, close parenthesis, and enter. So angle A is approximately 32.3 degrees. And now from here we know the sum of the interior angles of any triangle is equal to 180 degrees, and therefore angle C is equal to 180 degrees minus the sum of 73.1 degrees and 32.3 degrees, which is 74.6 degrees. And now the triangle is solved. Let's take a look at a second example. In this example, we're given the lengths of all 3 sides. Let's begin by labeling each side. And now let's determine the measure of the largest angle, which in our case should be angle C, because angle C is opposite the longest side, which means we'll be using this version of the law of cosines, where angle C is on the right side of the equation. C squared is 59.3 squared equals A squared plus B squared, which is 25.4 squared plus 42.8 squared, and then minus 2 times A times B times cosine C, which is 2 times 25.4 times 42.8 times cosine C. I now need to solve this equation for cosine C. So let's first subtract 25.4 squared and 42.8 squared. This will give us 59.3 squared minus 25.4 squared minus 42.8 squared equals negative 2 times 25.4 times 42.8 times cosine C. And now to solve for cosine C, we divide both sides by this product. Simplifying, this quotient is equal to 1, giving us cosine C is equal to the quotient on the left. And now to solve for C, we take the inverse cosine on both sides. Simplifying on the right side, we now have angle C. Angle C is equal to the inverse cosine of this quotient. And now we go to the calculator. We enter second cosine for inverse cosine, and then we need the numerator and denominator in parentheses. So we have open parenthesis, and then the numerator, close parenthesis, and then divided by the denominator in parentheses, open parenthesis, the denominator, close parenthesis for the inverse cosine, and enter. Running to one decimal place, angle C is approximately 118.6 degrees. But let's store this exact angle in the variable C. We do this by pressing store, and then alpha program for C, and then enter. So again, we have C is approximately 118.6 degrees. Let's go ahead and label this on the triangle. And now because we have an angle in the length of the opposite side, we can use the law of sines to determine the measure of angle A or the measure of angle B. Let's use the law of sines and determine the measure of angle A. Using the law of sines, we have the sine of angle A divided by the length of side A, which is 25.4, must equal the sine of the known angle, which is approximately 118.6 degrees. We use the exact measure when we go to the calculator, and then divided by the length of the opposite side, which is 59.3. And now let's go ahead and cross multiply and solve for sine A. This gives us 59.3 times sine of angle A is equal to 25.4 times the sine of 118.6 degrees. And now we divide both sides by 59.3. Simplifying, we have sine A is equal to the quotient on the right. And now we take the inverse sine on both sides of the equation to solve for angle A, which gives us the measure of angle A is equal to the inverse sine of this quotient. And now going back to the calculator, we enter second sine for inverse sine, and then we need the numerator in parentheses. So we have open parenthesis, 25.4 times the sine. Now we don't want to use 118.6. We could use this value here to 4 decimal places, but because we have the exact value in C, we will press alpha program for C, close parenthesis for the sine function, close parenthesis for the numerator, and then this is divided by 59.3, close parenthesis, and enter. Angle A is approximately 22.1 degrees. And now we can find the measure of angle B because we know the sum of the interior angles must be 180 degrees. And therefore angle B must be equal to 180 degrees minus the sum of 22.1 degrees and 118.6 degrees. Actually, this is an approximation because these are rounded values, which gives us 39.3 degrees for the measure of angle B. And now the triangle is solved. I hope you found this helpful. Okay, welcome to a video on applications of the law of cosines. Let's go ahead and review the law of cosines first. Remember, there are three forms to the law of cosines. The important part to remember is whatever angle we're using here on the right side, we must use the opposite side on the other side of the equal sign. An engineering firm decides to bid on a proposed tunnel through a mountain. To find the tunnel length, the measurements shown are taken. Part A, how long is the tunnel? Part B, the cost is $4,500 per foot. If the company wants a 20% profit, what is the bid amount? Okay, let's go ahead and start by finding this length here. Let's go ahead and call this side A. So this would be angle A. This will be side B. And this will be side C. So using the law of cosines, A squared must equal B squared plus C squared minus 2 times B times C times cosine A. Now we need to solve for A. You may want to check these on your calculator, but now we're going to add and subtract on the right side. So we have A squared equals 579,532.05. Now we can take the square root of both sides. So we have A is approximately 761 yards. So this is part A, how long is the tunnel? For part B, the cost is $4,500 per foot, and they want to know what is the bid amount if they want a 20% profit. Let's take this information over to the next screen. So first we have 761 yards of tunnel to dig, but the cost is in feet. So let's go ahead and convert this to feet. 1 yard is equal to 3 feet. So the units of yards simplify out, and we're left with 761 times 3 will give us the total number of feet. That's 2,283 feet. And the cost is $4,500 per foot. So the cost to drill that tunnel is going to be $10,273,500, but that's just the cost. If they want a profit of 20%, well, 100% plus 20%, we want 120% of this amount, or the cost. So we'll multiply this by 1.2, and that'll give us the bid amount. So it looks like we'll have $12,328,200. Remember, to find the percent of a number, you just convert to a decimal and multiply. Okay, we have time for one more application problem. There's a transmission tower near I-10. The range of the service from the tower forms a 47-degree angle and a range of 28 miles to one section of I-10 and 31 miles to another point on I-10. If a driver is traveling at 50 miles per hour, how long will she have service? So the difficult part about this one is going to be the setup. So let's go ahead and label this as our road. So here's I-10. There's a transmission tower, let's say, to the west, and it forms a 47-degree angle. So the transmission goes out from the tower like this, forming a 47-degree angle, and the range is 28 miles to one section of I-10 and 31 miles to the other. So let's just label this 28 miles and this 31 miles. This would be the distance where the driver would have service. So let's go ahead and label this D. We first need to find this length and then determine how long it will take that driver to go that distance driving 50 miles per hour. So again, we can find the value of D using the law of cosines. Remember, if we have the side D, or D squared, on the left side of the equation, we'll have cosine 47 degrees on the right. So we'll have D squared equals 28 squared plus 31 squared minus 2 times 28 times 31 times cosine 47 degrees. Remember, if we use this angle, then the side opposite of that angle will be on the left side of our equation by itself. Let's go ahead and start simplifying the right side. So d squared is equal to 561.0508. Now we'll take the square root of both sides to find the value of d. Remember, d would have to be positive, so d is going to be approximately equal to 24 miles. So the distance here is approximately 24 miles. So there's a 24-mile distance where the driver will have service. Now, since the driver is traveling 50 miles per hour, the question really becomes, how long will it take the driver to travel 24 miles? Because that's how long the driver will have service from this transmission tower. So since distance equals rate times time, time would equal the distance divided by the rate. The distance is 24 miles, and the rate is 50 miles per hour. This quotient will give us the time in hours, which is 0.48 hours. Let's go to the next screen and determine how many minutes this would be. 0.48 hours. Well, there's 60 minutes in 1 hour. The units of hours simplify out, so 0.48 times 60. So the driver would have service for approximately 29 minutes. Now the reason I'm always rounding to, now notice how I'm rounding to 2 significant digits, and the reason I am is because notice that all of the given information has 2 significant digits, so I'm maintaining that consistency throughout this problem. Sometimes textbooks ask you to round to a specific place value. Okay, I hope you found this video helpful. Thank you and have a good day.
We want to determine the measure of the largest angle in this triangle given the length of 3 sides. Well, the largest angle will be across from the longest side, and since this is the longest side, this is the angle we want to determine the measure of. Now I can use the law of cosines to determine the measure of this angle. The law of cosines is usually expressed 3 different ways. If we want to use this form of the law of cosines, we're going to want to label this angle here angle A for the angle that we'll use. So if this is angle A, then the opposite side will be side A, and the other 2 sides that form angle A will be sides B and side C in no particular order. Let's go ahead and call this B and we'll call this C. And now we can go ahead and apply the law of cosines. So we're going to have A squared, or 26 squared, equals B squared plus C squared, or 10 squared, plus 23 squared, minus 2 times B times C times the cosine of angle A. So now we'll simplify this and then solve for cosine A. 26 squared is 676, 10 squared is 100, 23 squared is equal to 529. Here we're going to have minus 2 times 10 times 23. That's going to be 460 times cosine A. Now we need to be a little bit careful here. This 460 is attached to the cosine by multiplication. So we can add these two, but we can't subtract 460. So we'll have 676 equals, this will be 629 minus 460 times cosine A. And now we can subtract 629 on both sides. This will be 0. Here we're going to have 47 equals negative 460 times cosine A. So now we'll divide by negative 460. So we have negative 47 over 460 is equal to cosine A. Now we can solve for A if we take inverse cosine on both sides. So on the right side, inverse cosine of cosine A is just equal to A. And now we can use the calculator to evaluate the left side. Let's make sure our calculator is in degree mode. So we'll go to the third row and highlight degree, press enter. Go back to the home screen. Now press second cosine, and then we'll type in negative 47 divided by 460. So angle A is approximately 95.9 degrees. Now if we need to determine the measure of the two other angles, we could use the law of sines to determine one other angle, and then since we know the sum of the interior angles of a triangle is equal to 180 degrees, we could determine the measure of the third angle by subtracting them from 180 degrees, but we have answered the question. Here's an application problem that can be solved using the law of cosines. A pilot flies in a straight path for 1 hour 30 minutes. She then takes a course correction heading 8 degrees to the left and flies 2 hours in the new direction. If she maintains a constant speed of 450 miles per hour, how far is she from her starting point? So according to this triangle, the plane would start out in this direction here and then turns in this direction here, and this would be the ending position. So the plane starts here and stops here. And the question is, how far is she from her starting position? So we want to determine the length of this side of the triangle. Let's go ahead and call it x. Now one thing that's a little bit tricky about this question is that this plane is traveling at 450 miles per hour for an hour and a half in one direction and 2 hours in another. But we need to determine the length of these sides of the triangle, which would be the distance traveled. So for example, if the plane is traveling 450 miles per hour for 1 hour 30 minutes or 1.5 hours, 1.5 times 450 will give us the distance traveled. So this distance here is going to be 675 miles. Then the plane turns and travels for 2 hours at the same speed. Well, 2 hours times 450 miles per hour is going to give us 900 miles. And now there's one more thing to consider. When she's traveling in this first path, she turns 8 degrees to the left at this point here. So if we were to extend this side here, this little angle here is 8 degrees. Therefore, this large angle in the triangle is going to be 180 degrees minus 8 degrees, or 172 degrees. Now, with the given information of this triangle, we can determine the length of x. When using the law of cosines, if we're going to use the measure of angle A, that means the side opposite angle A is going to be on the left side of the equation by itself. And it's also true that sides B and C would form the given angle, in this case 172 degrees. So if we want to apply this formula, x will be in the position of A, and B and C would be the other two sides. It doesn't matter which one's B and which one's C. So we're going to have x squared equals 900 squared plus 675 squared minus 2 times 900 times 675 times cosine 172 degrees. Now let's go ahead and evaluate this on our calculator. Let's start by making sure that we're in degree mode, which we are. So if we're careful, we can type this in all in one step. We'll have 900 squared plus 675 squared minus 2 times 900 times 675 times cosine 172 degrees. Now remember, this is x squared, so we have x squared equals 2,468,800. Let's just call it 0.7. Now to determine the value of x, we'll take the square root of both sides of the equation. And since x is a distance, we're only worried about the principal square root, or positive square root. So we have the square root of 2,468,800.7. So the plane has traveled approximately 1,571 miles. I hope this example was helpful. A 141-foot tower is located on the side of a mountain that is inclined 33 degrees to the horizontal. So looking at the diagram below, here's the tower that is 141 feet tall, and because the mountain is inclined 33 degrees to the horizontal, this angle here measures 33 degrees. A guy wire, which is a support wire, is attached to the top of the tower and anchored at a point 72 feet downhill from the base of the tower. So this red segment here would be the guy wire, and because it's anchored 72 feet downhill from the base of the tower, we know the measure of this length here is 72 feet. Our goal here is to find the shortest length of the wire needed for the guy wire. Let's go ahead and say the length of this red segment here, the guy wire, has a length of x feet. Notice how if we focus on this obtuse triangle here, if we knew the measure of this obtuse angle formed by these two sides, which we know the length of, we could use the law of cosines to determine the length of x. So let's first focus on determining this obtuse angle in this obtuse triangle. To do this, we'll use a property of parallel lines cut by a transversal. So if we have two parallel lines cut by a transversal, like this, one of the properties is that alternate interior angles are equal. For example, this angle would have the same measure as this angle. So if we apply this to our diagram and we use the horizontal as one of the parallel lines, and we form a second parallel line that passes through the vertex of this obtuse angle, it might look something like this. And because this angle measures 33 degrees, the alternate interior angle is also 33 degrees, which would be this acute angle here. So this angle measures 33 degrees, but also notice this parallel line forms a right triangle here, where this would be the right angle, which measures 90 degrees. Which means the obtuse angle in this obtuse triangle would be 90 degrees plus 33 degrees, or 123 degrees. So now we know the measure of the obtuse angle in our triangle. This obtuse angle here is 123 degrees. So now we can apply the law of cosines to determine the length of the guy wire, or the length of x. Remember, when applying the law of cosines, this side here on the left side of the equal sign, in this case A, is always opposite the angle used on the right side, in this case angle A. So because we're trying to find x, we'll have x squared here on the left, and we'll use 123 degrees as the angle on the right. And sides B and C would be the two sides that form the known angle. So applying the law of cosines to our obtuse triangle, we would have x squared equals 72 squared plus 141 squared, and then minus 2 times 72 times 141 times cosine of the angle formed by the two sides we know the length of, which is our angle 123 degrees. So we'd have x squared equals, and now we'll go to the calculator to evaluate the right side. Let's first verify we are in degree mode, so we'll press the mode key. Notice how degree is highlighted. So go back to the home screen, and we'll enter 72 squared plus 141 squared minus 2 times 72 times 141 times cosine 123 degrees. Enter. So here's the value of x squared, 36,123.35.
or we should say approximately. And now to find the length of x, we'll take the square root of both sides, and we're only concerned about the positive square root because x is a length. So let's go back to the calculator one more time. Since we already have this value in here, since taking the square root is equivalent to raising it to the 1/2 power, we could just press the exponent key and then enter the exponent of 1/2 and then press enter. This would be the same thing as taking the square root of 36,123.35097. So the approximate length of the guy wire would be 190.06 feet. So we can say the shortest length of the wire is approximately 190 and 6/100ths, or 0.06 feet. I hope you found this helpful. A steep mountain is inclined 72 degrees to the horizontal and rises to a height of 3,500 feet above the surrounding plain. So using this first sentence, we can model the mountain using this right triangle here, or half of the mountain, where the angle of inclination is 72 degrees, labeled here, and the height of the mountain would be 3,500 feet. A cable car is to be installed running to the top of the mountain from a point 800 feet out in the plain from the base of the mountain. So the length of side AD here would be 800 feet. So point D is where the cable car would start, and from here it runs to the top of the mountain at point B. So side BD represents the path of the cable car, and our goal is to find the shortest length of the cable needed, or the length of side BD. So let's go ahead and label side BD side C. Now looking at our diagram, notice how we have this right triangle, triangle ABC, and we also have this obtuse triangle, triangle ABD. So it'll take us 2 steps to find the length of side C. We'll eventually apply the law of cosines using this obtuse triangle, but before we do this, we need to gather some additional information. First, notice how the angle here that measures 72 degrees and angle BAD would be supplementary or form a straight angle, and therefore their sum must be 180 degrees, which means angle BAD would be equal to 180 degrees minus 72 degrees, or 108 degrees. So this angle here is 108 degrees. But now before we can apply the law of cosines to this obtuse triangle to find the length of side C, since we'll be using this angle that measures 108 degrees, we have to know the length of the 2 sides that form this angle. Well, we know side AD is 800 feet, but we don't know the length of side AB. Let's label side AB side M, and we can find the length of M using the right triangle, triangle ABC, and right triangle trigonometry. Using the angle that measures 72 degrees, notice how we know the measure of the opposite side is 3,500 feet, and side M would be the hypotenuse. So because we're using the opposite side and hypotenuse, we can use the sine function to determine the length of side M. The sine of 72 degrees must be equal to the ratio of the opposite side to the hypotenuse, or in this case, 3,500 divided by M. Now remember, we can do this because we are working with a right triangle. And now to solve for M, we would multiply both sides by M, which would give us M times sine 72 degrees equals 3,500. Divide both sides by sine 72 degrees. And now we'll go to the calculator to determine this quotient. We should first verify that we are in degree mode, so we'll press the mode key. Notice how degree is highlighted, so we'll go back to the home screen and enter 3,500 divided by sine 72 degrees. So M is approximately 3,680.12 feet.
Let's go ahead and label this in our diagram. And now using the obtuse triangle, or this orange triangle here, we can apply the law of cosines to determine the length of side C. Let's set this up on the next slide. The law of cosines is given here below. The main thing to remember here is that if we use side A here on the left, the relationship is that angle A would be opposite side A, and the sides that form angle A would be sides B and C. So if we want to find the length of BD, which we called side C, we would use the law of cosines in the form C squared equals the two other sides would be AD and side AB. So we'd have the length of AD squared plus the length of AB squared minus 2 times the length of AD times the length of AB times cosine of the angle opposite side C, which measures 108 degrees. Now we'll fill in the known values. We'd have C squared equals AD squared would be 800 squared plus AB squared is 3680.12 squared minus 2 times 800 times 3680.12 times cosine 108 degrees. And now we'll go back to the calculator to determine C squared. We already know we're in degree mode, so we'll press 800 squared plus 3680.12 squared minus 2 times 800 times 3680.12 times cosine 108 degrees. And we already know we're in degree mode, so we'll press enter. So C squared is equal to 16,002,834.61. And now we know C is a length, so C has to be positive. So we'll take the principal square root of both sides of the equation. And now we'll go back to the calculator. Remember, taking the square root is the same as raising something to the 1/2 power. So because we have this value already in the calculator, we could just press the exponent key of the caret and then raise the previous answer to the 1/2 power and enter. Notice how this would be equivalent to taking the square root of 16,002,834.61. Either way, C is approximately 4,000.35 feet. Which is the shortest length of the cable needed for the cable car, which again is the length of side C. This is approximately 4,000.35 feet. I hope you found this helpful.